one, so we are going to go through a couple of questions involving equations and inequalities. The first one says I have 2x into brackets x minus 3 is equals to 0, and I need to solve for it. What's nice is most of it has been done for us, so we can immediately go into dividing it up into its factors and saying if the one factor equals 0 or the other factor equals 0, then the statement will be true. So that means x will either have a value of 0 or x will have a value of of positive 3. The next question asks us to determine the value of x correct 2 decimal places. Now that means we are going to use this over here, the quadratic formula. In order to do that, we first need to arrange it into the form ax plus bx plus c is equals to 0. So that's what I'm doing right now. And just to make it obvious to everyone, I'm going to write down that a has a value of 3, b has a value of -2, and c has a value of -4. So now we substitute those into the equation where we say that b is -2, and it's plus or minus. There's a square root sign, and we've got -2 squared minus 4 times by 3 times by -4 over 2 times by a, which is 3. Now at this point you use your calculator immediately. You don't try and do this in your head, that's just silly. And we would get the answer of x is equals to 1,54, or x is equals to -0,87. The reason we get two answers is because in the first we are going to, let's just erase this, we're going to use the plus, the square root of all of those, and then in the next one we are going to do the minus of the square root. Let's just do that. And that's how we get to those answers. There are a number of different ways we could solve this inequality. The way I personally like to do it is I will draw the number line and I will fill in my two critical points, which is going to be 1 and 4. And the way I got that is I need either this bracket to have a value of 0 or this bracket to have a value of 0. For that to happen over here, x needs a value of 1 because 1 minus 1 is 0. And for that to happen over here, it needs to be 4 because 4 minus 4 would be 0. So those are my two critical points. Now I am going to do a little jot over here. I'll do x minus 1 and 4 minus x. And I'm going to substitute a random point, let's make this 0, into these two equations. So if I do that over here and I go 0 minus 1, what kind of value am I going to get? And by kind of value, I mean, is it positive or negative? It would give me a negative answer. Then if I substituted 0 in for x over here, I would do 4 minus 0, which would give me a positive value. Moving on to the next part, I'm going to choose the value of, let's make it 2, to substitute in just to see what kind of answer I would get. X, if x is 2 and I'm subtracting 1, that means I am going to get a positive answer. And over here, the 4 minus 2 would also give me a positive answer. Lastly, let's put in a value of 5 and substitute it. 5 minus 1 is going to give me a positive answer. So that's positive, and then if I do 4 minus 5, I am going to get a negative answer. Now at this point I'm going to go back to my number line, and I'm just going to draw those dots on the number line to indicate that both of the values, well, it includes 1 and it includes 4 because I've got more than or equal to 4. So if it's more than, that's a funny, more than or equal to 0. If it's more than, that's a very fancy way of saying that I want this side over here to have a positive value. So I'm looking for all of the values that exist between those 2 points. I'm just going to get rid of some green for us. And now, once again, this is just the calculations I'm doing. Now, a trick I have for setting up the inequality then is to draw the x where the line is going to be. Then I'll fill in my inequality signs. And the reason I do this is because it just makes it easier to see where the x goes in relation to the numbers. Now, this is one way to write your answer. You could also do it in set builder notation, where you say x is an element of, and it goes between 1 and 4. If you do it this way, you need to keep in mind that these brackets must be square, because it's including the value of 1, and it's including the value of 4 over there. Now, just on a side note, if I had a completely different question and I wanted to show that my answer is, this is once again completely different question, anything above 3, x could be. That means I can write this, if I do it in set builder notation, I can write it as it includes 3, and it goes all the way up to infinity. Now, because infinity by its very nature can't be included, we put the rounded bracket. Question 1.1.4 is actually asking us to use a very specific skill. It tells us we need to use the skill by showing us the square root on this side. And when we see that, we've got to remember that it wants us to square both sides to get rid of that square root. And remember, this is an equation, so whatever we do to one side, we need to balance out by doing it to the other side as well. So this makes life a lot easier. We've got 5 minus x, and then on the other side, we're going to square the binomial, which will come out like that. And now that we've got that, we can actually rearrange it into being a trinomial like this. And that's going to be 3x minus 4. I'm going to make it look a little bit more pretty by putting the equals on the other side. It means exactly the same thing, it's just the more polite way to write something. Now I need to factorize this in order to solve for it, and I know I need to factorize it because I've got an x squared. And because it's got three terms, it's a trinomial, so I'm factorizing a trinomial. My two factors of x squared are going to be x and x. And let's go with -1 and 4 as the other two terms. And I know that because -1 times by 4 will give me -4. But if I multiply out these brackets as well, I'm going to get a middle term of 3x. Okay, so now we can solve for it. And we know that if one of the factors equals to 0 or the other factor is equals to 0, the statement will be true. So x can either be 1 or x could be -4. In question 1.2, we are asked to solve for x and y simultaneously, and then we're given these two formulas. There are a number of different ways we could go around this or about this. One of the important things to remember is that you must always tell the person who's looking at your work exactly what you're doing. So with this particular one, I am going to make x equal to 2y minus 4. And I am going to call this equation number 1. I'll also rewrite the other equation to the side just so that I can show that I'm going to call this one equation number 2. So I am now going to substitute 1 into 2. And that's why we say what we're doing or labeling it, because then everybody knows exactly what we're doing. Sorry, just writing. So we're replacing all of the x's with 2y minus 4. And now we're going to multiply it out. And as you can see, I showed a whole lot of different steps with the multiplying out. And then before I decided to factorize the trinomial, I multiplied through by -1 because that'll just make my life easier. So I've got y squared minus 4y minus 21 is equals to 0. It is a trinomial, so my factors of y squared are going to be y, and my factors of 21 will be, or -21 will be -7 and 3. -7 times 3 gives me -21, and if I multiply this all out, I will get a middle term of -4y. So of course that means that y minus 7 will equal 0, or y plus 3 will equal to 0, and you'll see I've left quite a big gap because that's going to make my next step much easier. Let's just give us more space. I am now going to subs. You see I'm going to cheat over here. The value of y into 1. And the reason I say I'm cheating is because I've got two sides of the equation. This statement will apply to this over here. Sorry, two different equations, not the same equation. And it will apply over here. So I know that x will equal 2 times whatever the value of y is. And over here it was 7. And it was then minus 4. Or over here, directly underneath the other one, I can do 2 and into brackets 3 minus 4. Now, x over here is going to be 10, and x over here is going to be 2. Now, one way you can show your answers is you do the arrows like this underneath each other. You could also say that x equals 10, y equals 7, or x equals 2 and y equals 3. So that's another way you could show it. My personal favorite, though, is to write it as a coordinate, and this we generally only do when we're trying to find the points of intersection between a parabola and a straight line graph. So those are the different ways you could write the answers. Generally, when we're asked to discuss the nature of the roots, like we are in question 1.3, we're talking about the value of b squared minus 4ac. And then you would figure out what that is, and based on that, make conclusions about this over here. However, this question's only worth 2 marks. And in order to get to b squared minus 4ac, I'm going to have to do a lot of multiplication out and stuff like that. This 2 marks is telling me I can do something different. And the only other thing I can see that I can do different is rearrange this equation. So I start by trying to solve it. And this is where I see something interesting happening. You need to think about it a little bit in order to see what I'm saying, and maybe it's become obvious to you now, maybe not. What I'm looking at is that on this side I've got a number that's squared, and we know from experience that any number that is multiplied by itself, any number that's squared, will give me a positive answer. However, in this case over here, they're saying it's equals to a negative answer, which means this question cannot happen. The roots do not exist There's nothing x can be in order to be negative 1. So we say there are no real roots. And it is important that you state that explicitly. There we go. It is the language that's used in question 1.4 that makes it more interesting. It says determine the value or values of p if g of x is equals to negative 2x squared minus px plus 3 and has a maximum value of 3 and 1 over 8. Now what that means is that I am going to have a parabola, and the parabola will have a maximum value. We don't know what x is going to be, but it will go to a height of 3 and 1 over 8. So it will be an upside down or negative parabola, and it will go up to over there. And that's what gives us a clue. If we can figure out what the value of x is, that will tell us what the value of p is going to be. And in order to figure out that, we've got to do some magic. Now the x value of the turning point can be calculated by going x is equals to negative b over 2a, and that's something you need to memorize. Let's look at this equation. A is equals to negative 2. B is equals to negative p. So let's substitute that in. X has a value of negative, into brackets, negative p, over 2 into brackets, negative 2. So that gives us a value of p over negative 4. And let's just make it look pretty by putting the negative in front of it. So if I know that's the value of x at that point, I can then substitute that in to the equation using y, the value of y, 3 and 1 over 8, to be the answer. I'll show you what I mean. So let's start by replacing all of the x's with the negative p over 4. Let's square that, minus p, and the x value was negative p over 4 plus 3. And I know if I substitute that value in for x over there, I'm going to get a y answer of 3 and 1 over 8. So that's why I put 3 and 1 over 8 over here. So as you can see, I multiplied out the brackets and I subtracted 3 and 1/8 from both sides. So this bracket over here, negative p over 4 squared, became p squared over 16. And when I multiplied those out, I got an answer of negative p squared over 8. Over here, I had negative p times by negative p over 4. So that gave me positive p squared over 4. I did something magical over here. I could see that I wanted a denominator of 8, so I changed to the common denominator of 8. And lastly, and that meant I multiplied both the numerator and the denominator by 2. Lastly, 3 subtract 3 and 1 over 8 gave me 1 over 8. I then added my like terms, and to be quite honest, I didn't need that 1 over there. Not sure why I put it there, but anyway. I divided both sides by 8, so that I was left with p squared minus 1. So it's almost as if, it looks as if the 8 just disappeared. Poof, just like that. And after that, I then factorized. So this means p will either have a value of 1 or p will have a value of negative 1. And that's it for now. Much love.